Great. 8:30. Welcome to our second HDF Clinic. If you were here last week, welcome back. If you are new, we welcome you all as much. And yeah, let's just jump right into it. The first thing is, since this is about your questions, and I will ask that probably many times today, are there any questions out there? Otherwise, I have some material prepared to go over, but this is all about your questions. So I'm going to pause here and raise your hand, unmute yourself, and ask a question if you have one. That's not the case. Okay, then I will just go ahead with my first item to talk about last week's highlights. In case you missed it, there was a fantastic webinar on Friday by Lucas Villarreal about HDF5 UDF, and the recording is now available on our YouTube channel, and I encourage you to go there and watch it. Very interesting. And also the recording of last week's HDF Clinic is available now online. If you want to catch up on that, it's there for you. I'm going to pause here again for a moment just to ask if there are any questions. Unmute yourself, raise your hand. This is all about your questions. Okay, I'll just continue. What's been happening on the forum? There were, to me, three things that caught my attention. Number one, there was the release of HDFql version 2.3.0. For those of you who may not be familiar with HDFql, it is an API for HDF5 that has a query language. That's the number one. It comes with a query language, and that query language is the same for all the different environments that HDFql supports. So HDFql supports C++, .NET. I believe there also are bindings, Python, .NET, and Java. And so there is this abstract query language, which looks and feels a lot like SQL if you're coming from that neck of the woods. But under the covers, it calls the C library and so forth, but all those details are hidden from you, and it's definitely a very convenient high-level interface. One of the highlights of this new release is that Rick added Excel import and export sorry, capabilities, and these capabilities do not depend on Excel or OLE, which is sort of the object linking embedding, the Windows technology. It does not depend on those. It's completely independent, so you can run it on Linux or on any platform. There's no need that you have Excel installed or anything. It's very nice, and if that's of interest to you, you would like to export, for example, data from HDF5 into Excel worksheets and workbooks, check it out, or the other way around. If you would like to import such data into HDF5, you can do that as well. Another one, somebody described what looks like a bug in HDFView. Based on the description, it appears the description is basically somebody creates one of these HDF5 stub files with external links in them that point to the root groups of other HDF5 files. And he reported that when he opens the stub file in HDFView, he can sort of traverse into these other files, but then if he goes into a subgroup there, he cannot see the data sets in those subgroups. And that might be a bug in HDF View. And we asked him for a minimum working example. We haven't gotten one yet. And this is just good practice. So I think everybody who joined in on this call is probably aware of that. But yeah, asking a question on the forum or coming to this clinic is a great opportunity to ask a question, but you improve your chances of getting a response and getting a timely response by providing an example that somebody at the help desk here or developer or even somebody out in the community can just take, run, they can reproduce your issue, and they might be able to spot immediately what's perhaps going wrong there and give you an answer quickly. If you just sort of, and I understand in some cases you have a project and you believe you have sort of narrowed down the spot, but you don't want to post your entire project and that may not be practical, then still I recommend, or we recommend, take the time in your own interest to produce such a minimum working example and then go to the forum, because if you don't do that, again, everybody tries to be helpful, but everybody is busy. Nobody is sitting out there waiting for you and your question and your issue. And but to maximize your chances of getting a response, that's typically a good strategy. And then something that I saw this morning that popped up, a gentleman was reporting a possible issue in Hyperslab selections in 1.10.7. The way he described it, it sounds like, well, we have these Hyperslab selections and you can apply certain set theoretic operations on them. For example, the union, that would be, the operation would be an H5S select or, and it appears that that is no longer, as I would put it in double quotes, commutative, which is he reports that if he does an H5D read on the union of selection A and or selection B, so the union would be an OR, the intersection would be an AND, so selection or selection B would be the union. That seems to work, but if he does the union the other way around, selection B or selection A, then he gets an error, and he reports that that was not the case in 1.10.6. Now, he probably, I'm sure somebody will look into that. I recall that there was some work done on Hyperslab selections in 1.10.7. If it's related to that, I don't know, but that was an interesting report for sure. Okay, that's what's happened on the forum, and I have some material prepared to talk about something that we get asked frequently. But before I do that, another chance, anybody out there that has a question related to their project, related to their work about HDF5, of course. Anybody out there, please unmute yourself and introduce yourself and ask your question. Okay, that doesn't seem to be the case. Then I will just continue. So one question that we get asked with some frequency, and we should sort of just document this as a frequently asked question somewhere, is what, if any, of the so-called ACID, and we'll explain that in a moment, properties of HDF operations are supported? And this typically, this is a question that comes if you worked in the context of some kind of database or transaction system. This is, and then you come to HDF5. That is a question that comes up naturally. Now, if you approach that question in the context of HDF5, things are a little different here, and I will try to explain why. Number one is, in a transaction system, of course, there is a state that that represents something. In reality, balances on people's accounts is a favorite. That represents the state of something, then there is such a state certainly for an HDF5 file. So let's assume you have an HDF5 file that was opened by an application for read-write with read-write access, that the state of this HDF5 file is actually not only represented by the bytes on disk or in persistent storage, but it's rather, you have to think about it, and I put sort of my UML cartoon down here. There is sort of part of that state that's represented by the bytes on disk, but then there is another part of this state that's represented by information, metadata, and buffers and so forth in memory. And it is true that sometimes the two get out of sync for all kinds of reasons, buffering purposes, caching, and so forth. And in the event of a catastrophic, in double quotes, failure, such as hardware failure like a power outage or a system crash or an application crash or something, because of this, call it split state, it is in a way impossible to predict exactly what is going to happen to that state. If the state is, you may lose some information, but you can recover from what is there on disk, or in the worst case, you cannot recover from what's there on disk. But what exactly is going to happen in these circumstances is difficult to predict, and I will try to explain why. Okay, the second thing I want to point out that, of course, this whole terminology framework of ACID, atomicity, consistency, isolation, and durability comes out of the sort of theory or the transaction framework. And this does not apply in the case of HDF5. So in HDF5, you can call a function like H5D read or H5A create or something like that. But a function call is not a transaction. There is no such thing as beginning a transaction or aborting a transaction or committing a transaction or doing a rollback. There's nothing like that in HDF5. So if we talk about these ACID properties, the atomicity, the consistency, the isolation and durability, we would have to first explain to ourselves what do those things mean in the context of HDF5. And before we do that, we have to talk about one more thing, which is, of course, the HDF5 library uses file system facilities to implement the operations that it does when it manipulates, going back to my cartoon here, when it manipulates these partial states, the bytes, the file format, and so forth in the file on disk, but also the structures that are there in memory. So then the question is, well, among the file systems that we have, what do these file systems support, or how do they define? How do you define what is ACID for a file system? And that is already slightly different from what it is for a transaction system. And on top of that, unfortunately, there is no one-to-one correspondence between, if you do a function call or call it an operation in HDF5, like an H5D write, it does not directly translate into an F write. Very differently, it may translate into multiple operations in a file system. And that's typically where you get in trouble then, because many file systems support some of these ACID properties at the level of an individual operation. But again, there is no concept of a transaction where if you bundle multiple of them together, they typically lose that property that some of them might have on an individual basis. That's another thing to keep in mind. Now, let's switch to acid. Okay, first one up is atomicity. So if you want a working definition for HDF5, and I encourage you not only to ask questions, but also if you disagree with my working definitions here, then please raise your hand and speak up. So my suggestion for atomicity would be to say, well, atomicity for HDF5 would be that all changes to an HDF5 state must complete or fail as a whole unit. So when I do, for example, an H5D write, that would be a change to the state of an HDF5 file, that must either complete or fail as a whole unit. Now, the first question is that supported in HDF5? And I believe the answer is no. The reason is that unfortunately, it cannot be boiled down strictly to, does my underlying file system support atomic writes? Most modern file systems do that, but for example, the ext2 file system that used to be standard on Linux years ago, for example, did not support atomic writes. But today, let's assume we support atomic writes. That is still not a guarantee that H5D write will behave in an atomic fashion, because many of the operations in HDF5 are in-place operations. So for example, let's say I do an H5D write to a chunk data set, and that H5D write means that I'm modifying 2 chunks. So let's further assume that the size of my chunk cache is such that only 1 chunk fits into that cache. So what will happen as part of this H5D write, my first chunk will go into cache, it will get written, and then it will get evicted from cache to bring in that second chunk. Now let's assume that first write was successful and something happens during that second write. Well, and also let's assume we can recover from that. So my H5D write call will have failed. It will return an error to the application, and that's fine. But the problem is, of course, now we have modified the state of our HDF5 file in a way that we cannot go back to the original state, because we have overwritten 1 chunk, and we do not have a copy of the original information, so we cannot go back. Even if we had that facility, we cannot go back to that. And then, of course, who knows what happened to that second chunk? Maybe it wasn't updated or in the file, but we could end up in a situation where we have a data set that on disk looks like, yeah, 1 chunk was updated, but the other wasn't updated. So the H5D write as a whole is not atomic. Simple example. So in general, the answer is no. There is no atomicity. Is there disagreement, comments before I continue? Okay, I'll move on. Consistency. Next one up. So my working definition for consistency would be an operation is a correct transformation of the HDF5 file state. And that's, I would give you that this is a little bit hand-wavy in the sense that in the case of databases, or let's say relational databases, this has a very well-defined meaning. Consistency means, for example, that as a result of a transaction, all the constraints that you might have on a table, on the columns in a table, or between columns in a table, or referential integrity constraints between tables, foreign keys and things like that, at the boundaries of a transaction all these constraints are valid. Now, in an HDF5 file, of course, there is no literal translation of this concept of consistency, but then if you want to interpret this in terms of the primitives that we have in HDF5 files, like links and groups and attributes and so forth, things are actually looking not too bad, but it really depends on how you define these integrity constraints, call it that. And you have to, in a way, assume that you are dealing with a correct program. And by correct program, I mean you can certainly do malicious, destructive things. You can provoke certain types of errors. I'll give you an example. In the API, for example, in the HDF5C API, there is a call where you can increment or decrement the reference count of a hard link, of an object. And so you can artificially set that to 0, which would send a message to the free space manager and say, that thing is gone. And let's say you do not delete that link. I mean, that link is still there in a group somewhere. So that way you can provoke the creation of an inconsistent state. And if this happens as a side effect of an application error, that certainly can happen. But and of course, you can come from this from another angle. One angle is to say, from a single application, no other application, no other access. You can also look at it now, if I have multiple different applications looking at the same file, will they always have a consistent view? In other words, will they see the same thing? Logically, at least. And there are special cases that make certain guarantees about certain scenarios. For example, in 110, we introduced this thing called Swimmer for single writer, multiple reader, where you can have a single process writing to an HDF5 file, and then a number of reading processes reading from that file. And we make the guarantee that without any inter-process communication, the readers are guaranteed that they never will read either data that's not there anymore because the writer has changed them or deleted. Now, I think we support only data set updates and extensions. We don't in the previous implementation of Swimmer, we don't support creating new objects, attributes, and so forth. But in Swimmer VFD, we do. So that will be available in Swimmer VFD. Nevertheless, yeah, we guarantee that these readers will never crash because, yeah, certain metadata hasn't been written, or they read something that's not really there or only partially there. So consistency, it really, the true answer is probably it depends. It's kind of yes or no, depending on how you define consistency. Any comments, questions related to that? No? Okay. Next one up, isolation, or sometimes people call it serialization. A working definition might be, even though operations might execute concurrently, it appears to each. Oh, it looks like I messed up my notes here. Even though operations execute concurrently, it appears to each operator. Yeah, I think that H is just wrong here. We have an operation or multiple operations executing concurrently, and if you take each of these operations, it will not see the effect of other operations. And in other words, it's serializable in the sense that it will appear as the other operations have happened before or after this operation, but never both simultaneously. And the question is this supported in HDF5? No. The first question would be, what would be concurrent operations? Well, the obvious examples would be multi-threading. You have multiple threads in the same application, or you have scenarios like multiple processes accessing the same file in the context of MPI, for example. And so when I say no here, I mean no out of the box, but then of course it depends. There are certain circumstances in which this can be supported. So for example, if you compile the HDF5 library with multi-threading enabled, then there is a global library lock in the current implementation that you acquire, and there's only one thread that can execute HDF5, an HDF5 function, and HDF5 change the state of the HDF5 file as a thread, and then once it leaves the library, another thread can sort of jump in and do its thing. But it's a real serialization of access, so it fits that pattern. But again, with the default library, which compiled without thread safety enabled, this is not the case. And if you do this with multiple threads, there's no isolation. You're just asking for trouble. Likewise for MPI, yeah, if you use the MPI IO driver, certainly multiple processes can access the same file. There could still be race conditions and so forth, but that would be a programming error. So out of the box, no, but under certain circumstances, perhaps. Finally, time is almost up. Let's talk about durability. That's probably the easiest next to atomicity. The working definition might be once an operation completes successfully, its changes to the file state survive failures. And of course, that's a clear no for HDF5. First of all, because of the, remember that picture, the split brain nature of the HDF5 file. In the case of a power loss, if updates to the state that have been made in RAM have not been propagated to disk yet, there's just that part of the information will be lost. And if it's metadata, then it might be that it will lead to corruption in partial state 1 and so forth. So nothing there. There's no transaction lock or anything like that. There were some experiments around the 110 release with journaling, but these types of experiments never made it into the mainstream release for a variety of reasons. But yeah, so unfortunately, there is no durability guarantee. So taken all together, several things to bear in mind. Number one is there is no concept of a transaction in HDF5 at this point. HDF heavily relies on file system facilities if we talk about native HDF5 files. You might have heard there are other implementations based on object stores, blah, 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 service-oriented approaches where this picture changes. I'm talking purely about HDF based on file system facilities. And then finally, how do you define asset? How do you define these individual things? Depending on that, your conclusion may change. But out of the box, it looks kind of bleak. On the other hand, I would say it's not really, HDF was not developed as a transaction manager or as a database system. And people are successful on the whole, despite these conceptual shortcomings, let's call it that. So that's, time is up. Thanks for coming. If there are any questions, hold them. We'll be back next week. And yeah, thanks for coming, and enjoy the rest of your day. Bye.